Hello and welcome. The next topic that we're going to look at is rates of reaction or rates of chemical reaction, and it's quite important that we'll be able to measure the rates of reaction because we can then change conditions of the reaction and therefore you can speed up or slow them down. Now, a couple of examples of the kinds of experiment or the kinds of reactions you might have come across are going to be as follows. Here I've got some marble chips in some acid. Could be hydrochloric acid or sulfuric acid, something like that. These marble chips usually something like calcium carbonate, but the point is when we react these two together we get a gas formed, and that gas can be collected by what we call a gas syringe. And this is just a way of measuring the volume of gas that is produced. So if we can measure the volume of gas produced, we can work out the rate of this reaction. So what happens is the gas comes up through this tube here into the gas syringe, and this will move back, and the volume of gas can be read off from the scale at the top there. So that's one way of measuring a chemical reaction. We're measuring the amount of product form, which is the gas. Now, a second way would be not to measure the volume of gas produced, but to look at the reduction in mass in the experiment. So again, same experiment, marble chips in acid, they're giving off the gas, it's going through this cotton wool here and into the atmosphere, and then we can measure the mass that is lost over time. So we can, over say 5-10 minutes, we can measure to see how much of that mass is lost, and that's another way of measuring the rate of a reaction. Another way, or another common reaction that we deal with, is something like acid again, but this time with magnesium strips. And in this case you can measure the time taken for the magnesium to disappear. And that magnesium reacts with the acid. Eventually, over a few minutes, it will disappear. The faster it disappears, the faster the reaction is. And this is another common experiment that you might have seen or might have to deal with. And the last one to look at is not a reaction between a solid and a liquid, as I've done here, but this is two liquids. We've got a chemical called sodium thiosulfate, and this can be reacted with acid. And what happens is it goes from clear to a cloudy solution. And the way we measure this often is to draw a cross on a piece of paper or on a tile. We look from above and we measure the time taken for the cross to disappear. So you'd probably get something like this. Here you're looking from above, you can see the cross on the tile, and after a few seconds reaction occurs and the cross disappears, and you can measure the time taken for the cross to disappear. Time taken for the cross to disappear, and that's a measure of the product formed. Okay, so these are common examples of how you might measure chemical reactions and the kinds of ones you might come across. The next thing I want to look at is how we would actually record this. So again, we've got our marble chips in acid. We're measuring the volume of gas given off by this reaction, and you could plot it on a graph like so. So what you notice is we start off with 0, so before the reaction actually begins we have a 0 volume of gas produced, and as time goes on more and more and more gas is collected in the syringe, and after a while the amount of gas that's collected levels off. You don't collect any more than a certain amount of gas, and this is because the reactants, either the acid or the marble chips, have been used up. Okay, so the reactants are used up, and therefore the gas produced, there's no more gas produced, so this is leveled off. This is the maximum amount of gas that can be produced. You could change the concentration of this reaction, or put more marble chips, or change a couple of other factors, and you might get a steeper graph. Steeper graph, or you might get a shallower graph, depending on how you change the conditions. But we'll talk about that more in a later video. So that's measuring the reactants that have been produced, and we've got a graph that looks like this. Sometimes if we use this example where the mass is being lost, our graph might look something like this. So we have a certain mass of apparatus to start off with, and as time goes on the mass gets lower and lower and lower because we are losing gas, and gas actually does have mass. So as that floats off into the atmosphere, we lose mass, and again this will level off when the reactants are used up. It won't go to zero in this case because it's the mass of the apparatus, so that means all of this will have mass, and that will be the mass here. But that's the point at which the reaction has stopped because the reactants have been used up. It doesn't go to zero because the apparatus itself has mass. Okay, so that's two ways of measuring a chemical reaction, by using graph or recording a chemical reaction, but you do need to know a couple of formulae in order to be able to measure the rates of reaction. The two formulae are: rate of reaction is the amount of reactant used, divided by time taken, and the second way is rate of reaction is the amount of product formed over time taken. Now I haven't put units in this particular example because the units depend on the measurements you've taken in your experiment. So this might be in seconds, this might be in minutes, the amount of reactant used might be in grams or centimeters cubed, or certainly the product might be in grams or centimeters cubed. So it depends on how you're measuring the reaction, but let me give you an example of how we might use these two formulae. Now, first one here, we've got this, which should be familiar apparatus by now. It says a reaction produces 12 centimeters cubed of gas in 4 minutes. Calculate the rate of reaction. Well, we're looking at the production of a product, so we'd use this second formula, and it says 12 centimeters cubed produced in 4 minutes. The time is 4 mins, so that would just be easily 3, and the units for this would be centimeters cubed per minute. Okay, so that's how that one will work. A second example would be to use the mass of the marble chips to use the second formula. So the mass of marble chips goes from 5 grams to 3 grams in 3 minutes. Calculate the rate of reaction. What's the mass that's been lost, or what's the amount of reactant used up? Well, we've gone from 5 grams to 3 grams, so that would be 2 grams in 3 minutes. And so the answer for that would be 0.67 grams per minute, and that would be the units for that particular example. Okay, so a quick introduction, a quick overview of rates of reaction, how we measure them and why they might be important. That's it for me for now. Thank you for watching.